Afternoon, everyone. Welcome to our webcast this afternoon. My name is Nigel Hamlin, and I'll be with my colleague Paul Saxton this afternoon just to take you through some exciting new topics that we'd like to share with you. So a little bit of housekeeping before we start, so hopefully you can all hear us nice and clearly. The recording, we will be recording today's session, so if any of your colleagues miss it or there are any topics you just want to refresh yourself on, then we're going to have a recording and we'll pop that up on our website and send you the links. Also, in terms of questions, you're all on mute, so there's a little panel on the side of the web service this afternoon. If you can pop your questions in there, what we'll do is we'll have a little Q&A at the end once we've covered the content of today. So we're going to have a little bit of an intro. Just talk to you a little bit about us for you guys that don't know EBEX. Then we're going to really focus on business intelligence and the modern data warehousing. So it is as much technology and approach. So it's really bringing those two components together to talk about this afternoon, and a sort of interesting way, not just with the technology, but the way we approach this this whole data warehousing concept. We're going to talk about the Azure platform, which is pretty key here, and then how data management has evolved and come to this point in time. And Paul is going to take us through that this afternoon. So just a little bit about EBEX. So for you guys that don't know us, we've been in business for some 17 years. Founded in 1999, we're still privately owned, and the directors that founded the business are still very much driving us forward into the future. We have 3 offices in the UK and some overseas offices in the Middle East and also in North America. So we're very focused on sort of UK, but also we're able to deploy global operations as well. So we focus on the full spectrum of Microsoft business solutions, ranging from data analytics and business intelligence that we're going to talk to you about this afternoon, but also we're a very established Dynamics partner across the full ERP range from AX through to NAV, and also CRM solutions, and we've deployed some pretty impressive global solutions. We're actually part of the an Inner Circle program from Microsoft, and that's less than 2% of partners. So I think there's 59 partners on a global basis part of that. So we're proud to be part of that program, and it gives us a close insight as to what what Microsoft have got coming along the line, and so we can share it with yourselves and put those into sensible solutions and strategies moving forward. So I think, Paul, I'm going to pass over to you at this point and share with our audience today some exciting new concepts that we're working with customers with at the present day.
Thanks, Nigel. Thanks for the introduction and the overview of EBEX. Hi, everybody. Thanks for taking the time out this afternoon to join our webinar session. I'm going to start off by talking about business intelligence and data warehousing and how it's changing, really. So hopefully for those of you that are experienced data management people that are on the call, and for those who maybe are looking at data management from either a higher level or outside of that main arena, these are the types of things that I guess you will have been used to in the past. This is the way that historically we've gone about data management and data warehousing. It's a process of effectively designing up front, and we do that through a series of customer interviews, through data profiling. Once we've got those designs in place and we've taken a traditional waterfall route to get those signed off, we'll start to extract, transform and load that information and build those extract, transform and load routines. They will populate a data warehouse. That data warehouse will be created in a star schema fashion. Once we've done that, we're likely to put some BI visualization tools on top. Now that might be through building a cube and then presenting the information to a visualization tool, or it might be directly to the star schemas itself. and they form the basis of our outputs. The common thread really that's running through that approach is that we build the data warehouse first. Now, if we think about what a traditional data warehouse looks like, this really represents a very simplistic data warehouse, at least at a very high level. So at the bottom, we've got our data sources. In the middle, we've got our staging database with our ETL routines. On top, we layer on the data warehouse itself. And then, of course, at the front end, we have our dashboard and dashboards and reports. Now, as far back as 2012, Gartner was talking about the fact that data warehousing has reached its tipping point and that we're seeing the biggest and most elaborate data management system changing. So that means our data warehouse is changing. Now, what do they mean really, and how has that presented itself? Well, if we think about our data warehouse again and take a look at it in its standard form, there are a few things that are happening to the data warehouse that are causing some cracks in that infrastructure. The first thing is our increasing data volumes. Now, obviously a data warehouse can scale, but given the large data volumes that we're seeing, the amount of data that we need to churn is causing us pain in terms of those ETL routines. How do we move that information, that much information around? And typically, you know, data warehouse ETL routines run overnight. We're starting to see situations where those overnight routines are taking longer and longer to complete, and in some cases they may not be finished by start of work the next day. In terms of transferring data and latency of data, we're under increasing pressure for real-time data and real-time analysis by our end users. They really want to get hold of the information and start to work with it right away. They're not wanting to wait overnight for that process to load. They're not even willing to wait for, you know, half an hour for an incremental process to happen. They really want real-time data. On top of that, we've got new data sources and types, information flowing through from devices and sensors, from the web and from social media. And of course, that information is both on-premise and cloud-borne. Now, all of those things combined are really adding to the pressure on our data warehouse and effectively breaking that architecture. It's not something that we can continue forwards with. Now, if we go back to Gartner and what they are calling this new approach to data warehousing, you'll see Gartner refer to this as logical data warehousing. From Microsoft's point of view, we'll hear Microsoft talk about this in terms of a modern data warehouse. Why do we need to change? I guess big things that we've talked about is the frequency of data, the speed that that data comes through, but also, of course, we've got structured, unstructured, and semi-structured data sources. Now, the traditional data warehouse was never really designed to take account of those different types of data sources. We've got data volumes that have gone from gigabytes to terabytes to petabytes, and all of those things creating those cracks in the armor of traditional data warehousing. This really leads to things that we're hearing from our customers, that the data warehouse is difficult, having difficulty on onboarding new data. The data structures that are there are quite rigid and take a reasonable amount of time to change. Data governance can be a very time-consuming process, and this really leads to, unfortunately, our data warehousing and BI team becoming disconnected from the business needs. They're just unable to respond to the needs of the business in a time frame that the business is looking for. So it's really about agility. So back to Microsoft's idea of a modern data warehouse, and for some of you out there, you may have seen a slide very similar to this before, which is really listing the different elements that make up Microsoft's modern data warehouse, with both those on-premise SQL Server elements and those Microsoft Azure-based elements as well. The key message for me from this slide really is that a modern or logical data warehouse is not a single database or database technology. It's a combination of technologies that deliver us a data warehouse platform which can meet the needs of our users. Now, this really makes sense if we start to think about the different elements that we have available from Microsoft right now. And this is something that we'll drill down on a little bit later. But I guess what I wanted to show here is that for modern data management, we really need different technologies to be able to account and deal with different requirements. The information that we have at a transactional level, of course, we have wrapped up in our SQL servers, and we can deal with those very effectively either on-premise or in the cloud. We also have our big data requirements, and for those types of requirements we're going to need different types of database structures. We're going to need different types of platforms to be able to deal with that kind of information, and really this is where Azure helps us. We're provided with lots of different database technologies that are better suited to those larger volumes, to those increasing frequency of changes. But the key here is pulling all of that back together again to provide the end users with something that's simple and easy to consume. That really is the role of our modern data warehouse. So let's take a look at the Azure Data Platform for a few seconds. Now, for those of you that are familiar with the Azure platform, this one slide really encompasses all of the elements that are available on Azure. Now, clearly, what we're going to be focusing on today are those two blocks that cover analytics and IoT and data. And I'm going to pick out some of the key components that I feel are really important for a data warehouse modernization program. So the first one is our Azure Sequel database. This is a fully managed database as a service which is built on SQL. There's almost zero administration required. We can effectively spin up an Azure Sequel database on Azure and connect to it in the way that we're currently familiar. So we can use SQL Server Management Studio to connect to that SQL Server database. The fact that it's sitting on the Azure cloud really shouldn't be a barrier to us utilizing the technology. The great thing about this database is that we can scale it very, very easily. We can either specify a processing size for that database or set it up in an elastic mode, which effectively allows us to scale up that SQL Server database as required. Now, this is really useful in data warehousing. We can spend a huge amount of time at the beginning of a project trying to figure out what hardware is required and how we need to scale the database to basically persist for the next 5 to 10 years. And that's a really challenging task because we don't always know what sort of performance we're going to get as we get to the year 8 and 9 and 10 of our estimate. What we can do here, of course, is we can start very small, build out a very small part of our data warehouse on the Azure SQL database, safe in the knowledge that as soon as we get to the point where we need to extend the server, we can do that very easily. Azure Document DB provides us with that NoSQL unstructured and semi-structured environment that we're increasingly needing as part of our data warehouse. This gives us a really flexible development platform for taking care of the type of data that historically we would have, quite frankly, struggled to deal with in a data warehousing environment. Again, this is something that can scale as required. Going a little further, for those of you that may have come across things like Hadoop and Spark, we've got Azure HDInsight. This allows us to scale to petabytes on demand. It's a technology which really allows us to deal with huge volumes of data and do schema on read. So effectively put the information, the data into that database and worry about how we're going to structure that data when we pull it out. Now, again, this is technology that historically may have been the remit of very large organizations and require very specialist knowledge to set up and configure. With Azure, this is something that within a few minutes, we can spin up as many Azure HDInsight clusters as we need. Taking that a step further and really fusing that SQL Azure database with the Hadoop style ability to store petabytes of data, we've got the Azure Sequel data warehouse. Now, unlike the Azure Sequel database, which we have to scale up in increments and scale down in increments and let the system take care of that for us, the Azure Sequel data warehouse can do that effectively on demand. We can turn the volume up to 11 while we're processing overnight. We can turn it back to 1 again while it's just ticking over the weekend. So it's a really great way of taking care of the kind of random nature of requirements that we have for dealing with processing and disk performance. Now, the interesting thing, again, I just want to reiterate that a modern data warehouse needn't necessarily be any one of these database technologies. It could be all of them or maybe just a few of them depending on your needs, and could still include an element of on-premise, of course. So let's just take a look at the evolution of data warehouses and data management. So if we take a look at the data management timeline, we can see the evolution of the theorists and really what was going on in the industry. We can see E.F. Codd inventing the relational modeling concept all the way through to Bill Inman beginning to discuss data warehousing in the 70s, and then seeing what was happening really with Ralph Kimball in the mid to late 80s. And the popularization of the star schema. We can also see how things have continued to progress with the data vault modeling that's been introduced by Dan Lindstedt. So let's take a look at some typical two-layered architecture, and this is really what we tend to see people at least aspiring to create when they create a data warehouse. We've got our source systems on the left-hand side, staging database following that, and our star schema data warehouse in the middle of the diagram there. What we then have is a series of reports that are built off of that and consumed by end users, sometimes via OLAP cubes, sometimes direct. What's interesting is that the end users are effectively allowed to connect to that data warehouse. So we have to be very careful with our data warehouse. We have to make sure that it's presentation ready and appropriate for our audience. It means that we have to structure the data warehouse in a way that makes it really simple for all of our end users to consume. That first slide was actually something that is classical Kimball architecture. If we move to a three-layer architecture, this is really what we saw from the likes of Bill Inman. Again, we see those first three elements being the same. Obviously, our sources are the same. We've got our first layer being staging, our second layer being the data warehouse, and our third layer, our data access layer, containing data marts and our OLAP cubes. And that's really important, that there are multiple marts and multiple cubes. So what happens here is, rather than allowing everybody to go directly to the data warehouse, we've got an extra layer that is shrinking down and simplifying the data access layer for our end users. And that's something that actually we're seeing more and more inside our customer base. So whether that's conscious or not, we're actually seeing this third layer architecture in place within our customers. So what does a modern data warehouse look like then? How has this three-layer architecture evolved? Well, it's evolved in a number of ways. The first thing that we can see on the top left-hand side is we've got an enterprise service bus. So we're allowing for information to flow through as raw data into our data warehouse in real time. You can also see that we've got information from a NoSQL source, which is flowing through to our staging, but also through to our raw data warehouse in real time. We've separated our raw data warehouse from the logic, from the business logic, and that business logic is an extra layer within our data warehouse. And then again, as with the previous diagram, our information delivery layer in this case is storing our star schemas, our data stores, our data marts, as well as error metrics and report collections. And that's really, for me, what shows a modern enterprise business intelligence solution. So some other things that are really important to take into account with this modern data warehousing approach in our enterprise data warehouse is, historically, we take our source systems, build our ETL, and our ETL would apply those business rules and change the data before it hits our staging database, then before it hits our data warehouse, before it goes out to our final outputs, which may have been OLAP cubes. Records are changed on the way, and that really has quite a big impact because it increases the complexity of the ETL routines. We've got to decide what we're doing with those business rules and how we're going to work with them. It introduces some compliance concerns because obviously the data isn't the same as the source system any longer, and it affects our long-term manageability. What we do instead is apply those business rules on the right-hand side. So where we saw the raw vault and the raw data and the business data on the three-tier slide, we're doing applying the business rules after we've loaded the data warehouse, and that simplifies our ETL routines, reduces the amount of times that we need to revisit our ETL routines, removes those compliance concerns. Other things that we do is we model the data differently. So typically relationships from our source systems that we're considering are modeled directly into our star schemas. So our one-to-many relationship is modeled in our data warehouse. The problem is that 5 years from now, that relationship may change in our source system, which is going to cause a problem in loading our star schema and require the redevelopment of ETL routines, staging database, data warehouse, and OLAP cubes. Of course, we may have the same problem when we're trying to load historic data because it had a different relationship to our current model. So what do we do about it? Well, effectively, we introduce a different mechanism for joining our data together. Data is linked together by a specific table called a link table. Our descriptive and transactional information are joined via hubs. The hubs allow us to connect multiple systems together, and the links allow us to connect different types of transactions and descriptive information together. But this link table also allows us to account for any type of relationship going forward. If we look what a modern structure would be, our satellite tables contain our descriptive and transactional information. Our hub tables contain the relationship between those satellite tables. So imagine a customer hub having a satellite table from our CRM system as a customer and our ERP system as a customer. The hub understands the relationship between the two different customer tables. The link then joins us through to the sales hub with a sales satellite table that contains our sales information from our ERP system and CRM system. By working in this way, it enables us to scale that enterprise data warehouse really quickly and easily. So we may start today with a Dynamics AX system, which has a few satellites and a couple of hubs here. We may then extend it to include information from Dynamics CRM, and we can do that by simply introducing a new link table and some new hub and satellite tables. We don't need to revisit the ETL routines for our Dynamics AX system because everything we put through is new. And then we might introduce, another element from another business which is effectively running Dynamics NAV. But again, we're adding to the enterprise data warehouse. We're not revisiting the structures that exist. We're not revisiting the ETL elements that exist. So what does this mean for development cost and agility? Well, basically, our star schema increases in cost and effort as time goes by. Every time we introduce a new data mart, we have to revisit the structures, the ETL routines, the business logic that populates the staging data warehouse and OLAP cubes and reports. With a modern enterprise data warehouse, we can take that problem away by introducing structures that, of course, require some implementation effort to start with, but over time we're reducing the amount of effort to keep adding new systems. So hopefully that's been interesting to you. We've covered quite a lot there, right the way from theory through to software, through to techniques. I hope that's been interesting. The next steps for you guys is to reach out to us at EBEX with any questions or concerns that you may have. Nigel, can I pass back over to you to wrap up?
Yeah, that's great, Paul. Thanks. Really concise and some very interesting topics there. A couple of questions from the floor. As I say, everyone out there, we have recorded the session today, so if anything you need to replay or share with your colleagues, we'll make that available to you. As I say, a couple of questions I've got through the panel. Right, where does Power BI fit in the scheme? I know Power BI is a bit of a hot topic at the moment. Where does Power BI fit in the overall program of activity? Paul, do you get a couple of views on that?
So I think that's a fantastic one, actually. I think if we think about where Power BI sits, it sits in that information mart on the right-hand side. It's really a way of us rapidly building out data models to provide self-service capability to individuals, but it really needs good quality information for its data source. And I think that's a really important thing to understand, that to be able to get information, good quality information to our end users, even as a managed self-service process, we need that data governance going on in the background.
Okay, another interesting one. It's to do with real-time dashboards and the ability to build real-time dashboards using the platform and approach.
That's right. So I think hopefully you saw the enterprise service bus there writing directly into the data warehouse to give us the opportunity to build content that's presented in real time. Again, this is a great piece of technology that's provided to us by Power BI as a front man, because effectively it can present that information in real time. One thing I wanted to add, Nigel, was just our approach with Power BI and this iterative approach to an implementation. So making sure that we're utilizing Power BI right from the get-go. We can use Power BI to help us mock up data structures that we might then use to help build that enterprise data warehouse. So I think that's just a really great way of making sure that we've understood the requirements of the business before we start to effectively build out the hard structures of the data warehouse itself.
Yep, sounds good, Paul. Got another one. Which Azure components provide tools for extracting and loading into the data warehouse in the new hub and link concept?
So we'd still be utilizing things like SQL Server integration services to do that for us. Of course, we still have the ability to use stored procedures too, but we're also able to move data around with the Azure Data Factory. That's not something that we've covered in this session, but effectively think of that as a cloud-hosted way of doing ETL.
This is an interesting one. I'm not sure we can answer it. It's what does the first project look like? I guess what coming from there is what you mentioned before is that the first projects take typically quite a long time because you spend a lot of time on the enterprise data warehouse, and I guess it's difficult to say what a first project would be. It would be based on particularly user requirements, but I guess if we got any view on whether that's sort of quicker, longer, a bit different to how a typical project would have been done in the past.
Yeah, I think the key thing is it depends really where you are on your BI journey. If you're starting from scratch, then that's going to be quite different from if you've already got an established data warehouse that you're wanting to modernize or append to. What's interesting is that hub and spoke idea allows us, hub and sat idea allows us to integrate your current data warehouse structures with the modern ones as an interim measure. So it's about taking a journey. I think the key thing, Nigel, is making sure that we're delivering value back to our end users frequently. So we tend to do that through a series of sprints, making sure that the business gets some deliverables every 3 to 4 weeks, rather than us going away and building the entire end-to-end solution right at the get-go.
Yeah, I think that's a very valid point there, Paul, because I think what we've experienced in the past, going back over the last sort of 10 years or so, is that these projects can take quite a long time to get moving, and that this sounds like a great way of getting momentum, really quickly and getting some value to the business, at the early stages of the project, as opposed to waiting, 3-6 months in, and everyone being a little bit underwhelmed, I guess. So that sounds quite an interesting way and quite some value of perhaps taking this approach.
That's right. So I'm really interested to those of you out there that want to get in touch with us. We'd be more than happy to discuss things in much more detail.
Just checking the last questions, and I think unless anyone's got any final questions, I think we'll wrap up. Appreciate your time. We've run over by a few minutes. Hopefully you found it useful. We are available for further discussions or meetings. We can be contacted at our email addresses or via your account managers to explore this concept further. Certainly if you have any other ideas and questions after you've had a chance to digest what we talked about, then more than willing to explore that further with you. So on behalf of Paul and myself, thanks for your time this afternoon, and have a great weekend, and hopefully we'll catch up with you all soon. Thanks for your time.
Thanks everybody. Bye-bye.